How does edge computing integration compare to fog computing? When we think about the future of technology, two terms often come up: edge computing and fog computing. How do they stack up against each other, especially in the context of extended reality technologies and metaverse platforms? Let's break it down. First, let's look at where data processing happens. Edge computing processes data right on the devices that create it, or on nearby gateway devices. This means that data does not have to travel far, allowing for real-time analytics with very low latency. This is especially important for applications in extended reality, where every millisecond counts for a smooth user experience. Fog computing, on the other hand, operates at a slightly different level. It processes data at intermediate nodes like local servers or Internet of Things gateways. This means it is not as close to the data source as edge computing. While fog computing provides additional resources, it does not process data directly on the original sensor devices. Next, let's talk about architecture. Edge computing has a simpler setup focused on individual devices. Each device handles its processing, making it easier to manage. Fog computing has a more complex architecture that involves multiple nodes working together. This allows for better resource management across different networks and devices. Security is another important factor. Edge computing keeps data on the original device, which reduces the risk of exposure during transmission. In contrast, fog computing has centralized management at the fog nodes, but this can lead to more data movement, increasing potential security risks. When it comes to network dependency, edge computing can function with little to no network connectivity. This is because processing happens locally on the devices. Fog computing, however, relies on a stable network to connect fog nodes with edge devices and the cloud. This makes fog computing better suited for larger-scale data management. Now, let's look at applications. Edge computing is ideal for scenarios that need immediate responses, such as healthcare monitoring or interactive experiences in extended reality. For instance, in a metaverse platform, edge computing allows for instant gesture recognition, making interactions feel seamless. Fog computing shines in situations where large volumes of data from many devices need to be processed. It is often used in smart grids or autonomous vehicles, where intermediate processing can ease the burden on cloud infrastructure. In summary, edge computing integration focuses on processing data at or near the source device, making it perfect for real-time applications in extended reality and metaverse platforms. Fog computing complements this by providing a network of intermediate nodes that help manage larger data flows. Both play important roles in the evolving world of technology, with edge computing often being the go-to for immediate responsiveness and fog computing managing broader data coordination.